Hey everyone, I am Arush and you are watching Connect Akash English. Please subscribe, like and share my channel so I will be motivated for creating technical guys. So let's get started. Today we are continuing our machine learning project series and this is our part 2, and in this video I am going to discuss how can you create your own custom AutoML. So here firstly I will divide this video in two parts. The first part is going to be the notebook part. In this part we will see how can we create an intro of that library that we are going to use to create a Python AutoML. Okay, so firstly we will see this thing, then we will see how can we convert that notebook in an interactive Streamlit web app. So for this thing I will open my Google Colab and we are continuing our part 1. So when you will open this, then search for colab.research.google.com. when you will search this thing, make sure it is HTTPS because there are so much fake sites and it can evenly hack your system if you will not notice that. So it is loading. When it will be loaded, you will see an interface like this, and it is loading. We are waiting for that. Okay, go to file, then new notebook. When you will do this thing, we will see an interface like this thing. It is loading, yeah, this kind of interface, and then you have to simply connect this thing and your notebook will be connected after a bit of time. So it is connecting and it is connected. So here I will write pip install pycaret. Okay, pip install pycaret. Now pycaret is a library that helps to work with some AutoML features. It is like AutoML, but it is not AutoML. And we will do one more thing. We will first see this thing. You can do that with evalML, and there are so much libraries that you can do with statically AutoML libraries, and that is not so much cool. But we will only not this thing. We will see how can we convert that to an interactive GUI so that you can communicate with your data with help of that GUI. So it is installing. Yeah, it's installed. Then you have to search for pycaret. Then go to pycaret.org and it's loading. Then go down, get started. Now we can cross the home tag. Then go down and down. Here you will see this thing. Now for classification use this code, and for regression use this. Make sure that is functional API. So we will firstly see how can we do this thing, then we will see others. Okay, so after doing this thing, we will firstly load the dataset from pycaret.dataset import get data, then shift enter. Now I am following the pycaret basic documentation, and this is as data sets, not data set. This is a spelling mistake. Then here we are I am just following the way of the GUI's classification, and it is loading. It's loaded. So this is the data set. Here we have purchase, week of price, and so much. Now I am gonna predict that on store column. So after doing this much, we will import from PyCaret. Now we have done our data ingestion part, and we will do this thing. From PyCaret dot classification import star. It means we are importing everything from the PyCaret's classification module. And when we will do this thing, then it is loaded, and we can simply say setup juice comma target is equal to suppose I say store. This is just for testing, don't take this thing as a real world example. So it is like this. We have a PyCaret experimentation. Sorry. So if we go to again this documentation, then session ID is optional. We can simply pass that or not. This is optional, so don't go on that. Okay. After doing this much part, now the main parts come, and that is model selection. And in this part we will see how can we select a pretty full model that works on the data with a good accuracy. So for doing this thing, we will see best is equal to compare. Now this is from the classification module. Remember this thing. Compare models. Then just run. It will simply do that from the setup, because we have already set up this here. So that's why it will automatically do this. And it is creating a data frame for us. So 42% is done, 45, 48, 54 and 60%. 66, 72%. It is almost done. 78, then 85%, then 91%, and it is done. So our best model is completed. Then we can use evaluate underscore model on the best. Now it will train the best model. So it is done. Okay, you can select everything that you need. See ROC curve, confusion matrix, threshold, precision, recall, prediction error, 0, 1, 2, 3, 4. Okay, it's almost. PyCaret is a very powerful library, so that's why it is giving us this kind of imputation graph. It can automatically done your data pre-processing also, so this is quite dangerous. Okay, then after referring the PyCaret documentation, we can see we can predict on the new data. So we will write predict data, then predict model, write the estimator, and that is best. Then the data that you have to run on, and data frame is data dot, is that data or juice? That is juice. Then here you have to pass the y column because we have to drop that column. So for doing that, we will simply drop it like this. Then x is equal to 1. Then run predict data. Okay, it has predicted the data, prediction label 1 1 1 1 and so much. Okay, after doing it like this, we can use y pred, but we can also do that manually. So after doing this much, we can simply save this model. So save model best model .pkl, run this thing, then it has saved it. Then go to files, it is here. We don't have to pass here pkl because it will automatically do that for us. And logs are already here, so you can read the logs if you want. I caret loaded data dash. Okay, so for the regression part, if you want to do the same thing for the regression, simply change this thing to regression and it will work. Just the same code, nothing else is new in regression. So now we can move to the part 2, and that is AutoML GUI, and you got a basic understanding in first part. As I told you, you have get a basic understanding how our logic will work, and we will do this thing in GUI. So for doing that, firstly we will import Streamlit as st, okay, as st. Then st dot set page config, and then page title AutoML. Then if you want, you can simply pass the logo path. Then it will automatically set the title. Then st.title AutoML like this. And if we want this much code here, conda, not like this. For running a Streamlit file, write a Streamlit run app.py and the file name instead of this thing. Streamlit run and then file name. Okay. Then it is running. It is loaded, and we have simply passed the title here. Now after doing this much code, we can simply pass with st.sidebar colon st.radio select task data ingestion, and in the option we will pass data ingestion. Then we can pass it data pre-processing, but we don't want that. And if you can use the ED analysis, you can also do that, but I am not doing that because that will be so advanced. You can simply use the wide data profiling library, and that is very simple, but I will not use that because it will take so much time. So after data ingestion, we have a model selection. Then we have downloading model, and we have only these three parts. So if we have not passed the way, so we will write here what we can write as the variable name. Let me think. Yeah, task. This will be good name. So if task is equal to data ingestion, then st.file uploader. Okay, we have to pass it like this: sidebar, st.sidebar. Then here pass put your file, then the file will be loaded here. Okay, and it will be a byte. If we select model selection, downloading model, it will only appear on data ingestion part. So if that is data ingestion, then do this thing. And if file is not none, then do this: df is equal to import pandas as pd, then pd dot read csv, and it can read the buffer also. So the buffer is file, and we can simply rerun this. And st dot data frame df. Let's see. So firstly I will go here and my YouTube, my YouTube directory, then go to AutoML, then housing.csv. Yeah, it's loaded. So in housing.csv we have only 4 columns. Let me maximize it. So we have 4 columns: RM, Alistat, PT ratio and MEDV. Okay, then you can simply download that, but I will not do that. You can search that also. It is also very amazing Streamlit component that is presented in new version of Streamlit. I know you don't know this thing. Then else if task, we can assign the file as none in global file. Else if task is double equal to model selection, like this. Then if file is none, then only do this, and that is st dot error. Please select the file we can remove this also because that is not necessary. Okay, then if we go here, model selection, please select the file, but it is assigned here. File is not defined. let's do it like this. File is not defined. File is equal to none. Then let's see. Please select file. Yeah, I select that. Oh, that's because the Streamlit cache, and we have to store this in cache, but that will be so advanced, so I am not doing that. I am simply going that here. I am simply taking it here to source file.csv, just like this. This is a very simple way, but Streamlit cache is so advanced and you cannot understand it. So here is source file. Here the file will be pd.readcsv file, and here you have to pass source file.csv, just like this. Then go at model selection, and that's gone, I know. And else, in else part. Now I hope it will work, so let me remove this file and go here and refresh. If it will so, please select the file, then it will work, and if it will not so, then there is some problem. Source file is not exist. Try accept. Try and accept. Try accept block. If that throws any error, then please select the file. Colon is not passed here. Then refresh it. It is here, and I upload a file in it and go here. Now that is gone, so it is working. So after doing this much, we can simply import the task level analysis. So here I will go in the try block. I will ask the user for the task is equal to st.select box task comma option is equal to options dot option. So options are, the first option is regression, the second option is classification. Okay, we have this. So we can simply import from pycaret dot classification import setup as setup clf. Then pull is not necessary. Compare CLFs. This will be a good name. Compare CLFs. And after this we have evaluate model. Evaluate CLFs. Then prediction is not required. then paste this again. Regression. This is all regression. Setup reg, compare reg, evaluate reg. Okay, then we can save this, refresh, and I forget to do a thing here. Label visibility is equal to hidden. Save this. Now let's see what will happen. Yeah, that's gone. Regression and classification. So if the task is double equal to regression, then simply load the file. Here we have the file. Then we will use these functions, and we also have to do here one thing. Target is equal to st.select box, select your target. Then options are going to be file dot columns, and then set up reg, and here this thing will be passed, our data frame. Then we have to pass the target, then we have to pass the label for target. Okay, then we can simply pull this data frame here. Setup df is equal to like this, then st dot data frame setup df. Let's see, and we also have to do one thing. If st dot button run, then only run this task, otherwise don't run this. Then go here, refresh, and it's like this. MEDV. Here is a parameter in it. Index false, because that is because this unnamed column. I will tell you why. Here if I go and housing.csv, then the index column will be added when I run to CSV, and it will be added if we remove index is equal to true. So then we have these columns, then MEDV, and this is a regression problem. Run this. Now let's see what it will give. I am waiting for its reply. Yeah, this much. Please select the file, but for some time I will remove this thing because it is little bit of disturbing me. Let me rerun this. Run. Okay. Now I knew it. Because here we have a function called pull CLF. And in regression we also have a function called pull CLF. This function is used for pulling a data frame. So for this thing we will do pull because we have just run the setup. And pull regression. Pull reg. Okay, then rerun this. Now let me see. I think it will work. Yeah, it's working. See, it's here, this thing, and session IDs, 4 generators, k-fold, and so much. Here, instead of simply writing that, we will write here star 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 star, and inside star star we will pull that data frame. So setup. So just like this. Now let's see. Yeah, it's here. So after the setup, we can simply do this compare model and evaluate. So for comparing models, we will use best is equal to compare regression. Then it will compare that. Then st.write hash then best performance of models st dot, and that thing is st dot data frame pull regression, just like this. Then if you go here, rerun this thing, then I hope we will see this. Yes, setup, but where is performance? Okay, it is running. I have not noticed this. See, it is running. It is pre-processing the dataset automatically. We don't have to do anything. It will automatically do that. See, my hands are up. I am not doing this. Here it is running. Then no further exploitation. Okay. Yeah, performance of model data frame is ready. Here we have GBR, gradient boost regressor. It is number 1 performance. And then random forest, then light GBM, extra trees, ADA boost, KNN, Huber regressor, Bayesian, Gridge, elastic net, ridge regression, linear regression, lasso regression, least angle regression, lasso least angle regression, ... There are so much. So I can't read them one by one. After doing this, we can simply do this. Best is equal to, and we can remove this. There is no problem. We can remove this thing. Then best is equal to evaluate regression. Then best will be here. Then if, and no need to pass here, if st.download button, and here pass the label download model comma data, and data is best. Then let's save this. Now let's rerun. Data ingestion, it is here. Then run. Setup. Let me see the progress from here. Performance of models. Evaluate. Oh, I forget. It have best. Then run this. Then it is set up. Performance of models. None type. Okay. So let's do it like this. From if st dot button download model, then after doing this you can simply import the pickle library. Now this is not that pickle that you are thinking. Import pickle as pkl, then pkl dot dump. Then you can simply write here model dot pkl d colon slash. This will be a good thing. D colon slash, and from pathlib import path, because we want that to be run in every operating system. So from pathlib import path. Then if we go here, rerun, then I hope we will see that setup is ready. Then our pre-processing, it's about to done. Yeah. So performance of model and download model button, and if I click on this button, then I hope the model will be saved. D colon slash. Here model is from the M. Where is the model? Model.pkl. That is a pkl file. it's not here. So pickle.dump. Okay, I have to pass here best comma, so that's why it is not working. And if it works on regression, then it will of course work on classification. So setup, then it is generating the performance of models. Yeah, performance of models. In fact, download model. Now let's see. Refresh. Now go down. Yeah, our model file is here. So that's it, guys. And I forget to do a thing here for the regression. After this, we have to also do the same thing for the classification. Then for the classification, we will set up classifier, pull CLF, compare CLFs, pull CLF, evaluate CLF, CLFs, then save, rerun, and if I run this, okay, that's because it is not a classification problem, it automatically identified that. So that's it, guys. This is in the video. I hope you like this video. Thank you, guys. Thanks for watching the video.